tell. Except for this is of course the beast. And there's nothing here except stratocumulus. And nothing here except stratocumulus.
And maybe the whole prevalence of stratocumulus, it says cold season.
Yeah. Might not be the hottest one.
Should be good to go.
Okay, ready to go?
You got the mic on?
Yeah. Is it too low?
Yep.
At this point,
Can you hear that?
if it's going to be wet, slushy snow, and
Okay, welcome to our weather discussion. We're thrilled to have our esteemed Professor Lang back from the hinterlands of coastal Newfoundland and Labrador. She was there just the last couple of weeks. I was there the 2 weeks before, and right now it looks like they're socked in. This is kind of what we learned a little bit about local weather. When you get easterly flow on the sort of north side of a cyclone, watch out. It can be just bad weather for taking off and landing, and I think that's probably what they're suffering from right. They canceled today, didn't they? Or was it yesterday?
Yesterday was.
Okay, yesterday was canceled and today's down. Okay, so a good call because the weather is not going to cooperate. But I think you had a pretty good adventure too.
Oh, yeah.
Yeah.
It was
So
great.
we've been getting one good data flight after another, and so it's been really great project. And we're going again next year, so with a bigger plane and probably bigger arguments as a result. But that'll be fun. Beautiful day outside today. I think this might be about the first day that we've cracked 45 degrees. I didn't have time to look because class comes right before Weather Watch, but first time we've cracked 45 degrees. If we've done it yet, I don't know if we have. But
+6, so that's 42.
yeah, so we're getting close. So we're not quite there yet. We might get there this afternoon. We will on Saturday. Whether it's today or tomorrow, I think it'll be the first time in many weeks. I don't know the last time. Maybe right around Christmas we had a couple of warm days. They were cloudy. I don't know if they got to 45.
We got 50 in early January, didn't we?
Oh, did we? We have a really warm day in early January. We're still on the break. I forgot about that. So it's been almost but more than a month. So a good long time. And in the intervening time, of course, we had a really widespread, really impressive cold air outbreak over both the central United States, the northeastern United States, and southern Canada, southeastern Canada. One day, I think it was right after I got back or just before I left, I can't remember now, the -40 isotherm at 500 millibars covered this huge area, southern Quebec, parts of Ontario, and parts of Labrador. And I don't think I'd ever seen it so widespread before. So that was really bitterly cold. Despite that, I have some interesting news to share with you about the 850 cold pool. I won't do that yet. So here's our current satellite movie.
John, the other aspect of this period from late December through now, or
Yeah.
from when the warm period ended in January through now, is we had a couple of impressive snowstorms.
Yeah.
Snow events, but then
Yeah.
not much significant replenishment over that time period, but with just a solid snow cover for a long period.
Very true. Yeah, the little bit that remains has not been augmented substantially in a long time. I think the whole time I was away, it didn't snow, which I was glad for because the men didn't have to shovel. But before that, we had a week, maybe middle of January, it was an inch or so every day of really light powder. So there was several days of shoveling there, but not very substantial shoveling, and that was what kept us through January, having snow on the ground, because without that, it would have all been gone. In fact, it may have been almost completely gone after that early warm period, despite the snowiest November day ever in Madison, followed by some snows in December.
And also a curious thing, if you could look at the METARs from the airport, 2 days ago, on the 11th, at 18Z, they reported 2 inches. Today, they're reporting 2 inches
Of snow?
of snow.
On the ground.
4/002.
So they've got a black body cavity right next to the right next to the observing site. It's like an ice house, and so they're trying to keep it.
I wonder if it's in the
I don't
same
understand that.
Take
Yeah,
a look on the satellite picture. There's no snow down here. It's all north.
well, it's right on the edge, but yeah, it's all up north. But that's one thing Michael asked me just as we sat down. If you looked at the satellite picture, what would the season be? Just looking at this without dates. And several clues. First, the snow cover is widespread. I kind of said mid-winter. And then he mentioned the stratocumulus with an obvious direction coming offshore. Pretty beastly storm in the southern Labrador Sea. Absolutely nothing in the tropics in the eastern, western Atlantic, and nothing in the eastern Pacific, which really points toward central cold season. Doesn't it?
Beastly's a bit much.
Well, it's a cavalcade of beasts. This is down probably in the 950s. There's one in the forecast that'll get down to 941. And in fact, it'll get there in express mode. It'll go from 987 to 942 in 24 hours. So sometimes that happens in the tropics. Maybe once or twice every few summers. It happens every winter in the Midwest.
Which makes them
multiple times. So
how could that be special? Anyway.
yeah, you're right. And the circulation is so strongly confined. It doesn't occur over huge areas like it does in the tropics. Those are really intense. Been gigantic circulation. Oh, wait a minute. I'm talking out of turn.
All right, okay.
Do you want to keep going?
No, you
Okay, all right. Okay, so, but a beautiful day here today, and conditions are nice across the entire eastern 2/3 of the country. There is, here's another clue about when exactly, maybe February or March, because when you start to get cutoffs off the Baja California coast, LA has its coldest month of the year at 8:50 in March, so we got to be getting close to March for cutoffs to be here, and so that'd be another clue I would have used to get us somewhere in the right realm. But that's the only place where we have any substantial southerly advection coming across the Baja, western Mexico, into the Four Corners area. And that's really the only place where there's substantial clouds, with the exception of some of the high terrain in the northern Rockies. In widespread snow, as we saw before. So, but no particularly well-organized storm systems across the entire continental 48. And then over the Maritimes, it's been a really stormy winter. I think probably more than normal in terms of the cyclones below 960. It's been great. So couldn't have been timed better. So let's take a look, Pete, if we could, at the water vapor. See if we see any swirlies within swirlies, which sometimes you do in the water vapor imagery. Yeah, look at this. 1, 2, 3 little swirlies all along this shear line, which is most likely the cold front. And so these features here are not always potent in terms of developing large-scale weather systems, but I'll bet you probably at the sea surface underneath some of these, not every one of them, there can sometimes be some quite interesting developments that occur there in the small, on the very small scale. But that's a nice sequence of them, and you can see them kind of rolling up at an almost regular distance along the shear line. I think you can see sometimes things like that happening here as well, right off the Carolina coast. Not quite toward Bermuda, but not quite doing it. And then here's another pretty decent disturbance, which I think doesn't show up so obviously in the visible satellite cloud images, but that's probably exactly the kind of thing that you'd want to leave from Goose Bay and go out there and sample this thing.
That thing's been there for like 7 days.
And it's
just
big
right there.
scale.
Yeah.
That's the thing that's really interesting to me about this one compared to what we were doing earlier, at least in my time on the project. We were looking at very much smaller scale ones, hoping for bigger scale ones. And that's what Flora is doing right now, is differentiating between small TPVs, which, I don't want to speak for Andrea, but I got tired of hearing about these little tiny things. I really did. In every one of the forecast discussions, that was the focus of them, and I thought, no, we're focusing on the wrong thing. We don't have a comprehensive view of the synoptic scale. This thing here is a different animal, and I think it did emerge out of the Arctic,
Yeah,
right, all by
as
itself.
it was being pinched off from the big.
Yeah,
Keep
right
it
on the
going.
crown of Quebec. That was the flight you were on, right?
Yeah.
Yeah, that was a good one. So these are really interesting features. I'm wondering if at the end of the winter they become more prevalent. They get better organized at the high latitudes, and then they're dripping circulation out of the polar regions, one by one, and they get congealed a little bit perhaps before they finally reach the boundary with the polar jet and then get involved and they're gone. I don't know.
I think I described it as a lava lamp. Like
Yeah, right, yeah. Exactly right. That's what they like. And the lava lamp substance is carrying circulation out of the high latitudes and throwing it away into the mid latitudes, where it just, at this time of year, it's just going to get squashed. Wouldn't it be nice if somebody was allowed to study for 3 years the transition between this winter regime and the spring regime? We should probably sit down and write our 4th version of the proposal on that. So hopefully this time will be a charm. Big upper trough off the west coast. You can see how dry it is in the middle and upper troposphere in the water vapor, and that's a signal of the intensity of that upper feature. And if you didn't really pay attention to that, it's clear there's really substantial southerly advection with some dynamics associated with it, which probably means a long flow speed changes and so on, and that gives you the bifurcating cloud mass over the Four Corners, which gives you a little bit more detail in the water vapor on that. So kind of interesting. One of the broad characteristics of January, it seems to me, and I'm saying this without having gone back to really take a look in detail, is that something akin to a ridge, either off the west coast or in the middle of the, in the first few longitude bands of the continental North America, has been prevalent. And then so we're always in the downstream northwesterly flow. That's kept us chilly. The whole month's been pretty cold. And it also has made it vortex rich in the eastern part of the domain. Although that same broad flow has carried a lot of those vortices, especially the smaller scale ones, rapidly to the east. So sometimes they don't have a long residence time. This has been the exception. And I'm glad that it has. We got a good chance to look at that one.
Right. And that pattern, it looks like it's about to change at least for the next.
Oh, is that right?
Yeah,
Okay.
with more of a trough
Okay.
in the west and a ridge over the central and eastern part of that.
Yeah, that's good. That's good for us for a lot of reasons. And it's good for the West. They've been really starved.
Right.
Keep on hearing from our colleagues in Seattle, no rain for a long time, so they're really having some trouble. It's going to rain while we're there next weekend, but it hasn't been raining much. Okay, let's take a look at the radar across the country, Pete, if we could. And so a little bit of lake effect coming off of in the broad northwesterly flow that's characterized the month, coming off Lake Superior across the Upper Peninsula and then over into Lake Huron. Here's the widespread showery activity across Arizona, parts of New Mexico, that's associated with that deeper trough off the coast and the southwesterly flow out to its east. And then right off the Pacific Northwest, a sort of put together band of precipitation right off the coast of Aberdeen, places like that, Olympia, and heading into the Puget Sound area. Then Florida's from Squim, so this is exactly the kind of flow that keeps them dry. They get like 5 inches of rain a year in the middle of the Olympic rainforest because the flow is the precipitation's blocked by the high terrain. The Mount Olympus is 9,200 feet high, so it's not a small mountain. And so with southwesterly flow, the lee side is dry as a bone, and Squim is particularly so. So very interesting. I found out today, speaking of that, that's so interesting, just that our department has somebody native from Squim, Washington, so she'll talk about that probably a lot. We have somebody in my 101 class today, guess what town she's from in Norway?
Bergen?
Bergen. Isn't that awesome? And I said, oh, that's the most famous city in meteorology. She said, really? I said, wait. So that's going to be fun. She answered her exam in pen today. Big mistake, but that's okay. Yeah, we do it by hand. Okay, now let's take a look at the super Pete's, if we could, Pete. But from Bergen, how do you like that? And I've been there once. Let's start at 500 millibars, if we could, Pete. So here's the 6 a.m. 500 millibar map from this morning. Map when we saw in the water vapor, those little ripples. Here's one of them right over Lake Superior. You can kind of see it in the 500 millibar map. A local spot of wind speeds almost surely greater than 80 knots. That's what it is here in Western Ontario, but that's with a weaker gradient in the analysis. This is stronger right north of Duluth, and it was immediately downwind of that. We saw that little precipitation band at hours subsequent to this that was probably tied to that little wave. So that's not just lake effect, it's got a dynamical underpinning as well. Here's a broad upper trough off the East Coast. There's the feature of interest that's kind of had people's attention and nurture for a long time. It's pretty chilly. It's minus 41 at its core at 500 millibars. And that's a very much a local cold spot. Look at how much warmer it is. It's in the mid to low 30s below zero around it, and you get to minus 41 in the analysis. So that's cold. That's a really cold tropopause. Low tropopause probably too. I bet it's not higher than about 500 or 450 millibars. So that's a perfect feature in a perfect position for reconnaissance from Goose Bay. Just about at the edge of the domain, but nonetheless it is. You can drop sondes over the land in Canada north of a line that's well south of this feature, so that was probably a really good target for a long time, which is great. Here's a really gigantic vortex structure over the archipelago. I don't know if this qualifies as one of these tropopause polar vortices, but it may well, and it's a good example of how if it is, they can amalgamate into gigantic structures, like the Great Red Spot almost, except it's a cyclone. And what happens to these as we go from winter to spring? You know, they're diabatically sustained by cooling, and so if the sun comes up, it stands to reason the cooling gets mitigated, and so what happens to them? Do you just lose the circulation by diabatic heating, or do you kind of encroach on the mid-latitudes and have the circulation really become ingested into the mid-latitude flow in a springtime stormy scenario? That's what we're hoping to investigate, and the interannual variability of those processes. Here's a big ridge just off the Aleutian chain and then the trough off the west coast, which had that little bit of precipitation far downstream of the trough axis. It's not really a particularly potent upper wave, but we saw maybe the far eastern edge of a widespread cloud shield. We'll look at the west coast satellite image in a minute. And then here's the upper trough that we saw most vividly, I think, in the water vapor, where it was dark, absolutely bone dry in the upper troposphere, and it was downstream of that, downstream of this 500 millibar trough, that we saw the widespread showery activity over Arizona and parts of New Mexico. So everything makes good sense from the large scale perspective. And the large cyclone in the southern Labrador Sea, just like many of them this month, unfortunately, never gets itself completely wrapped up. So here's the baroclinic zone at 500 millibars, cold front, and then the warm front extending. Here's a little bit of a thermal ridge south of the tip of Greenland, but it's not really wrapping around into the Labrador Sea. We didn't get, well, I was there anyway, we didn't really get a deeply occluded cyclone sitting there. They were always pretty deep cyclones, but they ended up then being fairly progressive at this latitude and moving straight toward Europe through Iceland or southern Greenland. It looks like this one is suffering the same fate. I say suffering because it's nice when they really wrap up there, but it hasn't happened too much. Okay, and of course widespread lack of observations, direct observations in the central U.S. I guess we've said enough about that. It doesn't make it better every time we talk about it. Let's go to 300 millibars and see what the jet looks like. So here's the 300 millibar jet. Big cyclone in the southern Labrador Sea is to the west of a fairly intense jet, 160 knots, minus 42. This is a low tropopause over Newfoundland and southeastern Labrador. And then we've got a fairly complicated jet structure over Alaska, the northeast part of the Gulf of Alaska, and then also just about heading onto the west coast. And then probably this is a subtropical part of the jet, I'm guessing, although I don't know that. We'll find out by going to higher elevation. So that's what the jet structure looks like. A little bit of a weak wind speed maxima in about the region we saw our precipitation feature, or downstream we saw the precipitation feature, and still an obvious trough at 300 millibars. So that's a deep mid to upper tropospheric trough that's passing right over us right now, or to our north. Let's see what it looks like at 200 Pete, and keep in reminder of where those jets are. So this is that's 300.
I know, I was just reminding
Yeah.
where the jets are.
Okay, thanks. And at 200, a level where we can be pretty sure we're looking at the core of the subtropical jet in most times of the cold season, you can see that the jet is weaker here. So that the wind speeds at 300 are stronger than they are at 200. That suggests that really we were seeing a polar jet on that feature because we're kind of through the jet core and into lower wind speeds above. This is different. This one here is maybe about the same wind speeds, 130-ish knots, as it was at 300 millibars. So that's curious. That could be one of these features that's almost vertically superposed polar and subtropical jet. And the fact that there's a northwesterly flow upstream of this feature would indicate perhaps there's been a migration of a polar type feature out of the high latitudes. And then the fact that the main core is somewhere around 30, 33 degrees north indicates perhaps that's the subtropical part of it. So cutting a cross section through that could be of interest. We won't do that today. Okay. West Coast satellite picture. Let's take a look at that.
What version would you like?
Let's do the infrared if we could. Yeah, so this is good. Oh, it's filled with things to talk about, so we can't talk about them all. We've already said something about this feature. This looks really nice. From this perspective, we're kind of squarely looking at the upper trough circulation a little bit better from this angle. And there's the widespread cloudiness. It's always asymmetric with upper troughs to the east. Not too much cloudiness to the west. There's good dynamical reasons for that, of which you're all aware. And so that's nicely connected to an identifiable structure. A giant gap in the ITCZ doesn't really flare up until southeast of Hawaii. There's the state of Hawaii. And so there you are with a little bit of ITCZ convection, but at least 30 or 40 degrees of longitude with almost nothing going on in the ITCZ. And then here's that feature off the west coast that was sort of shown up as a trophy feature, a broad trophy feature at 500 millibars. I think the same at 300 with a weak jet, relatively weak jet south of it. Look at the differentiation amongst all of these open cellular convective entities. Some of them are deep enough to show up in this blue, so they're pretty cold. And that's probably at the core of the circulation, the coldest air aloft. And then the ones on the periphery, not quite as deep, but about equally spaced with the ones that are deeper. So the depth is really a function, I bet, of just the stability. So the colder it is aloft, the less stable the stratification, easier it is for convection to penetrate and get cold enough to show up as that temperature. These here, undergoing roughly the same thermodynamics and broad dynamics, just don't have the stability edge to get that much deeper, the little bit of a threshold extra of vertical penetration and thereby radiate at lower temperatures. And then further to the west, not quite at the date line, a little bit east of the date line, you've got this broad flow emanating out of the subtropics at least. There's Hawaii, so it is subtropics. And kind of ridginess over the eastern part of the Bering Sea. These are really cold cloud tops, so this is probably deep activity, deep convective type activity in that plume. But it's not obviously connected to a cyclone unless we're losing that connection by the obliqueness of the angle. There's something right there that gives me a sense that perhaps there is a circulation in the far central or western Bering Sea that has a bearing on the behavior of that cloud mass. But I always like these things. And as I've told you a million times, my sense is if you had this picture and you could precisely measure the spacing between the various convective elements you might have a pretty good idea what the 500 millibar temperature is. I didn't check that when we looked at the 500 millibar map, but let's just put it to the test. These are spacious, widespread enough. I think we're probably in the minus 32 to minus 35 range, right off the coast of Washington, British Columbia. Let's go back to 500 millibars, see if that's true. Minus 38, it's actually colder than I thought, so that's even better. So that's where the cluster of the coldest cloud tops were, and then you can see the periphery is about minus 32 to minus 35. So,
And probably there is a local potential vorticity maxima right over the coldest there.
probably right here, exactly right. So there's
So
a,
that's what's associated with the lower stability in that.
and probably the organization. It's a little bit more organized. Yeah, the whole thing looks different. Subtly, but to the trained eye, you do see the difference, yeah. Okay, let me stop with showing you the 850 millibar cold pool. I promise you that. I mean, I don't mean to make this seem like a big surprise, present, but it is a present. You know that we've been running at record level. And I didn't wait till this morning to make my calculation. I figured I wouldn't have time, and I was right. I'm glad I did it. I went through all the end of the day on February 11th, so that was Wednesday. Through February 11th, which is right there, this is the warmest December 1st through February 11th of all time. That goes back to 1948, or 1949, because we didn't have December of 47. So 1949. So that's a long, long time. The closest competitor is 2014, 13-14, and or 14-15, sorry. Can you go ahead one slide here, Pete? This is what the last 17 days of February looked like in that record-breaking year. And we are running neck and neck with that year right now. So that means we have probably got to get a pretty decent warm-up around the hemisphere sometime between now and the end of the month. But there's also room for getting back to relatively cold conditions, which is about 1 standard deviation below a daily calendar average. So if we just went flat across like this, I think we'd win. So there may be a gold medal at the end of February for this year. It's going to be really, really close. I don't think there's a chance we'll fall into third. We'll either win or be in second place. And so, and this comes on the heels of the announcement that the endangerment clause, or whatever it was, about carbon dioxide is no longer considered a dangerous pollutant, because someone decided that we're just going to avert our eyes to the coming problems that come from that. It's perfect timing to re-energize people's attention to this problem. If this is the warmest year ever, we will have in the last 12 years had 3 out of those 12 years be the all-time warmest ever by this measure. And there's nothing special about this measure. It's just kind of curious and a gay curiosity, perhaps even. But you could probably find a million other ways to make this same basic lower tropospheric measurement, and you'd still have the same answer, that 3 out of the last 12 years have been all-time records for warmth in the wintertime in the Northern Hemisphere. So we can shut our eyes if we want, but everybody in here was a kid once, and everybody did this once. I didn't just, burn down this thing in my dad's workroom or, bust the radio. I'm going to pretend I didn't do it. There's always a reckoning. And when the whole government of the United States decides, let's just act like a 2-year-old and pretend that dad won't find out, that's a really big problem. So here we are, on the threshold of another record, and it's getting to be routine. I'm still hoping we get it, as you know. So I'll keep you updated. I won't be here next Friday, so the suspense will build. I will be back on the 27th. We'll have the day before the end, so I'll have all the way through the 26th. With 2 days to go, we'll know what's going on. And maybe then it'll be enough to just uncork the champagne or drown our sorrows, one or the other. Okay, so that's all I have. Thanks. Remember last time I gave you my phone?
Thanks, John. And it's actually worse than just your dad not finding out what you did in the workroom. It's your grandkids finding out what you did to the planet. Not so the planet's always going to be here, but in terms of the climate of the planet changing. So this is really a serious decision that was made yesterday, which is going to have, unfortunately, some perhaps negative consequences in the decades to come. What I'd like to first go to is let's go to the Climate Prediction Center first, and just get a sense of, and let's go to the drought. We have a drought monitor right here. And as John was saying earlier, it's been dry over the western part of the United States. Back in, I guess it was December and parts of January, actually California got a significant amount of rainfall and snowfall, and they actually ended their drought. I think there was at least a period of time which no part of California was in any sort of drought category. And I guess with the recent dryness, it's now beginning to creep into the northern part of the state. But much of the western United States has had just a bone dry winter with very little snowfall, a lot of the ski resorts suffering. But that's going to be actually going to begin to change a little bit over the west as the pattern begins to change, just at least subtly, with more of a trough and more precipitation in the western United States and a drier, milder pattern over the central and eastern part of the United States. But a significant part of the country is just dry, which is, what does this mean for planting coming up in the next several weeks in the southeastern part of the United States, and the growth of plants, the emergence of those plants as you get into later into the spring. So something to just watch out for in terms of these dry conditions. Let's go back, please, to go one more click. Oh, we can stay here. We can just stay here. We'll do it from the NOAA page. Just the outlook for temperature. You can see above normal. Again, the intensity of the red here does not mean it's going to be really much warmer here. It just means the likelihood of being above normal, whether it's a degree or whether it's 5 degrees above normal, is likely over the southern part of the United States, and again, below normal conditions over the western United States. And this is for the next 6 to 10 days. And if we advance to the later period, let's actually stick with it, 6 to 10 days. Also above normal precipitation over the western and northern parts of the United States, and fairly dry across the south central United States and the southeastern. So this is the precip outlook for the next 6 to 10 days. And we can advance that about a week or so forward in the 8 to 14, and pretty much the same sort of pattern with below normal temperatures expected over the west, including Alaska, and then over the south central part of the United States, likelihood of above normal temperatures. And again, this doesn't say how much above, it just says that the probability is that you're going to be above normal in those regions in red, the warmer colors. And for precipitation, stop being relatively dry here, still wet in the west and more in the midsection of the country, which is going to be useful again for farmers as they begin to prepare their fields for planting in the next several weeks. Getting some moisture in the ground, water in the ground is going to be great. And then dry over the southern part of the United States and the southwest. So let's now zoom into our current weather. And we'll start with my favorite, John's favorite diagram, the meteorogram, although I hear some people call it meteogram.
They call it meteor.
Exclusive.
They're wrong. They're wrong. It's a meteorogram. Back in my day. Which is your day, John. Okay. And also back in my day, we didn't continually show bad dew point traces, but it'll get fixed before the end of the semester, I'll say that. Yeah. Here's the temperature forecast from the NAM, from the WRF initialized using the NAM from this morning. And it's not doing well temperature-wise in terms of we've already exceeded 6 degrees Celsius today, so it is going to be a bit warmer. That's actually something I think is kind of interesting. Why we've gotten so warm in the last couple of days. And John and I were talking about it this morning, and it could be just really the rapid decrease in snow cover is contributing to more insulation, but still that has to do two things. It still has to evaporate water off the surface, melt any remaining snow, and again, obviously less is being reflected back out into space because the ground is now darker, the albedo is decreased. So maybe that's why these sort of model temperatures are kind of lagging behind what reality is showing. Could we just take a brief cut, Pete, and look at the METARs from the last 2 days?
Yeah, we should have looked at the state of Wisconsin surface ops too. But
Yeah, we can do that. We can do that.
Dew
Yeah.
points in the minus 70s degrees C will do a lot of sublimation too, as you know. So, although I don't know if they're. Is that just a plotting error that you've got on that? Honestly,
It actually is a WRF to GEMPEG error, conversion error. So
it
it's
has
too
nothing to do
decorative.
with the model. Okay.
Right,
Okay.
but it's the user of the software tools. It's not, I'm not going to say it's the software itself. But this used to work before. It could be a change in the plan. So here is the last 48 hours. So this is on the 11th going into the 12th at 0Z. This is the 2 inches of snow that was reported a couple days ago, about 36 hours ago. And if we go further ahead in this, this is through the 12th yesterday. Temperatures getting up to about +3 or so. The high was 3.3, so that is 6 plus 38 for yesterday. And then we go into tonight. Let's just go forward again. Yeah, I don't see how we still have 2 inches of 2 inches of snow when we had that period of time when we were above freezing. So 2 inches, but we're now at 6.1, 44, I guess, right?
Yeah.
It's actually 44. So we're doing pretty well compared to what the actual forecasted temperatures were. The other element, if we move this away for just a second, Pete, is the fact that we have a dry weekend coming up. So the weather's going to be relatively quiet, I think, over us, and we'll see that. Let's go to the time height section, please. The time height section shows that the dynamical tropopause is well to our north. This green line right here, or well, it's far to the north, but also really high up. Here's the 1.5 PVU surface. We see in yellow again the isotropes, and see a hint of a modestly stable layer really close to the surface that actually strengthens a little bit during the day on Sundays, which can prevent really deep mixing to warm up. And some modest vertical motions. These are, I believe, in meters per second, but they're not this is not particularly strong, and it's dry for us. So this afternoon, kind of getting somewhat of a mixed layer there. Tomorrow afternoon, something similar, but you can see the southwesterly winds, very light, staying southerly, and then becoming more northwesterly. As a little bit of cold advection comes in, we get a little bit of backing of winds with height. At least these are geostrophic backing winds with height. Things a little bit cooler if you remember that temperature trace. So maybe Sunday is going to be just a little bit cooler than Saturday, but not by much. Maybe some clouds tomorrow afternoon with relative humidities increasing in the middle and lower troposphere, but this is going to be a dry weekend coming up. So let's look at the surface maps to get a sense of things. Actually, before we go to surface, I wanted to look at just the PV and sort of mid-troposphere 315. Okay, it's a couple of really interesting things that we can see on this map. First of all, that big vortex, that fairly deep vortex that was over northeastern Canada really shows up nicely here. We'll see it also in the vorticity. You can see this that fairly broad trough that was off the west coast of the United States as it's coming on shore. Downstream of it, that plume of area of precipitation forming, and you can see this is probably, at least in part, some evidence of latent heat release occurring in the lower troposphere with that precipitation as it comes across the Baja Peninsula of Mexico. And then further to the west on the edge of the domain, fairly deep trough out in the Gulf of Alaska and northeastern Pacific that's approaching the west coast of the United States. All right, let's animate this. See a couple things. We'll stop it and maybe we'll just step forward in this, please. This little nicely rolling up potential vorticity maxima. If you go back one step for just a second, this is what we saw at 500 millibars, and also at 300 we saw some evidence of it with a wind maximum just to the south of it. This little vorticity maxima downstream of it is where we saw some of the precipitation falling. So it could have been also not just lake effect, but maybe lake enhanced as that trough is probably by this time we go a step ahead. It's past this area, and so just the colder temperatures behind it could be destabilizing the atmosphere there. This rolls up really nicely as it heads off the east coast. I don't believe this is going to generate much in the way of a significant cyclogenesis event, partly because all the barochronicity has been pushed way, way offshore. And so there's nothing for this PV anomaly to sort of latch onto. Meanwhile, in the western part of the United States, this trough has moved sort of definitely inland, and then downstream of it, we see this broad ridge developing, low values of PV kind of emanating here, which may be associated again with some latent heating that's occurring downstream of it, where conditions are moist enough for vertical motion to produce precipitation. And we have this really strong jet now impinging upon the west coast of the United States. So probably a rain event beginning to set up for parts of Washington State. And we can let this just animate forward in time. One thing to watch in the southeastern United States, we'll see this in the SPC page, is the possibility of some severe weather over the southeastern United States as this trough moves eastward and kind of nicely rolls up, gets a bit more energetic, but with significant curvature aloft. I think this could become a more prominent player in terms of producing some interesting convective weather over the south central part of the United States. If all the wind profiles and water vapor line up correctly. And SPC is suggesting that that might happen. So let's go to the surface map with the precipitation on it, and we'll let it loop once, then we'll step forward, please, Pete. Okay, so you can see that. So here's the precipitation, again, ahead of that upper trough, and you can see that you get some fairly impressive precipitation amounts occur during the day tomorrow over parts of Arkansas and Louisiana as we step forward in this. The model does pick up correctly if you go back to the beginning and just step forward, please. That precip ahead of the, you can sort of see in this area right here, nicely pick that up. And so that's a fairly consistent feature, so a lot of perhaps synoptic scale forcing for ascent just downstream of this, and it moves off the coast. You don't see much, you see some troughing here, but again, there's no big wrap up in a cyclogenesis event. Also, it's interesting to note, as vigorous as that upper trough was, if you let it go right back to the beginning, here's that really deep upper trough with very low thicknesses beneath it. As it heads toward the, just offshore into the Atlantic, again, not much in the way of cyclogenesis occurring with it because it's, again, the baroclinicity is either tied really closely to the vortex itself and there's not much of a broad baroclinic zone offshore for it to latch onto. So some reasons why it perhaps doesn't generate a significant cyclone. There is a cyclone that begins to deepen, but it's not as impressive as you might think given the intensity of the wave.
When you think about the, if you don't mind me saying.
No, please.
If you think about that sort of vacuum cleaner model of the isotropes and their structures
Right.
moving along with an isolated upper PV anomaly, there's no mutual interaction because there's nothing to interact with. It's just the feature itself moving
Right.
through and bending the isotropes and then having relative flow created. It's almost like that's what you get when you're deep in the cold air.
Right.
So when you get over relatively warmer water, you might get a little bit more bang for the sloped buck, but you
Right.
don't really get any development.
Right, because sort of if you will, the skirt beneath the upper trough,
Yeah.
those isotropes that sort of form that structure are just nice and flat all the way out. So
Right.
there is no steep gradient where you can begin to have the isotropes bunch up, getting frontogenesis occurring and some sort of dynamical
No
interaction.
low-level circulation at all. It's
Right.
just kind of flowing through this broad structure.
Yeah. So I think that's probably a likely reason why this isn't, at least in the first 60 hours of this forecast,
I think my
doing
maps
much.
do a cross-section through that feature,
Oh, yeah?
if we wanted to look at it.
Oh, yeah. Please, you
Yeah.
can direct me.
Those are excellent cross-sections.
It's a confluence. And then, the nurture. And then if you scroll down a little bit, then dynamic turbocost potential, those maps.
Yeah, these are awesome.
So this is the potential temperature on the dynamic tropopause as the 2 PBU surface. And that little purple blob with a star on it. So we're taking a cross section through the location of the coldest potential temperature on the dynamic tropopause. And then that other kind of like tealy dot is the strongest gradient of potential temperature on the dynamic tropopause. And then we draw the line to take the cross section. And then if you scroll down, that's the cross section.
Oh, that's beautiful.
Yeah, isn't that nice?
Yeah.
Just exactly illustrates what we're talking about.
All right, and so you can see this, again, these isotropes that sort of bow up underneath it, nice and flat to the, I guess, east-southeast of it and to the west-northwest of it. But that's sort of a classic textbook cross-section through a
Yeah.
PV anomaly. In fact, we were just talking about that today in 801. Enhanced stratification, warm above, cold beneath.
Yeah, and there's a little bit, the purpley colored fills are ozone, so you can see the ozone kind of sinking in the middle.
Purpley fill.
The,
Talking about
the pinky
this.
color filled.
Oh, yeah, all of that shading, okay, I see.
Yeah.
Okay,
Yeah,
Nice.
that's pretty awesome. So it's just this big vortex,
Yeah.
not connecting to anything at the ground, but it has a structure that allows, as it moves, upslope flow on its east side and downslope flow on its west side. And that's what gives you the cloudiness to the extent there is any.
Right.
and the extreme dryness inside of it, which was
Yeah,
also
yeah.
indicated in the water vapor.
Very interesting, yeah.
This is really neat. And that circulation, as you're just mentioning, doesn't quite, that cyclonic circulation, doesn't quite make it to the ground, at least on the east side of this. There is
Yeah.
some just to the west.
Yeah,
That's really nice.
Yeah.
Thanks for that.
Yeah.
Okay. Let's go back to the surface map for just a second. We'll quickly look at the, go back to that loop and we'll step forward really quickly. You can stop it and then we'll just jump at 6-12 hours into it. Couple clicks. Okay, so over us, over the upper Midwest, again, 540 thickness line over us, and it's hopefully will be advancing northward. There it goes toward Green Bay, comes back at night. But the big thing for this weekend, just south of us, is going to be that upper trough, and the precipitation associated with it will not quite reach our latitudes. It will stay dry, but I think some of the clouds will come in briefly tomorrow afternoon as this passes by. Interestingly enough, I think having the clouds and precipitation to our southwest is going to keep temperatures down to our southwest. We'll see this when we look at the local maps that zoom in on the upper Midwest. Parts of Iowa are going to be cooler tomorrow, but then they warm up really rapidly. I think it's because the insulation gets stronger once the cloudiness moves out. So, but again, light winds tomorrow. This is really a pretty quiet forecast for us. Again, for the south central United States and the southeast, I guess on the lookout for some, maybe some potential for some severe weather. We continue clicking ahead. Okay, some significant convection tomorrow afternoon or evening into early Sunday morning. And then just more general rainfall. The other thing of interest, and we'll take a quick look when we go to the pivotal, is the fact that that the rainfall that's forecast for the southeastern part of the United States and the mid-Atlantic, this has been varying a lot over the last week. About a week ago, people were posting things on X and other media about a significant snowstorm, maybe a foot or two of snow in areas that are just tired of seeing snow on the ground for this long a period. I think some places are reaching their longest period ever for at least an inch or more of snow on the ground in the winter. So this is significant. But what happens is this is all liquid precipitation, first of all. But we'll see shortly that how this upper trough is handled in the forecast and how the precipitation shield associated with it in particular is forecast. A lot of variability in the position of how far north this rain is going to get. Anywhere from a potentially totally dry weekend to one that's wet with at least half an inch of liquid precipitation. And maybe in some forecasts have just fringes of snow in the higher elevations of the Appalachians. But for us, quiet. And we're at the end of the loop here. So let's quickly go down to the local area maps, surface maps, 3 hours. And a couple neat things here, just a nice example of frontogenesis that's enhanced by, I think, a change in the temperature structure over Iowa. And we'll see that in a second. So let's go to tomorrow afternoon. Okay. So we're here in Madison with southerly winds. Again, you can look at the isotopes here. We're at +6 or so. I'll probably add a few degrees at least 4 degrees more on this. Gets into the upper 40s based on what's happening today. The model's been a little bit behind. And temperatures to our southwest are still about 10 degrees or so Celsius. And you can see the precipitation even further south. So there's probably a shield of clouds that are keeping temperatures somewhat suppressed here. As we step forward in time, watch as this gradient gets somewhat disorganized and then begins to kind of clean up as it gets warm well to our southwest. And you see a nice front beginning to form as we move towards Sunday afternoon. So let's keep on plotting. There it is. Nice example of diffluence. Your frontogenesis along this axis right here, stretching, deformation, strong front, and these temperatures now get into the over +10, +12, maybe +14, just to the south here because things have warmed up. But the front, at least in this forecast, doesn't make it really too far to the north. We have this northwesterly flow that sets up. So I think it's going to be interesting to see the interplay between, again, once the clouds by now are going to be well to the east of this region. How warm could we get on Sunday if we were able to truly get this front well to our north? I mean, that gets us into the low 50s, or we're going to be just under 50 for Sunday. And also with that warm advection, I think it's probably dry here, so we're probably not going to see much in the way of low clouds, but maybe there are even some high clouds perhaps beginning to develop.
Yeah, what a weird day. Gray sky, slate gray, 46 degrees maybe.
Right, but I think based on the vertical profile we saw in the time height section, we might actually be clear here, but I think it's what's happening further to the southwest as well. So interesting forecast dilemma. So let's take a look quickly at the, go to pivotal. And I'd like to go to, say, 60 hours in the forecast. And then do a couple of things. Let's go to 60. And let's go here, please, Pete. And go to compare models. This runs. All right. Darn it. If you click on here, just to log me in, if it will do that, I don't know if I have to give, forget it, let's go back. Doesn't have it here. I have the password and all that, but it's going to be a pain to get it connected. Let's go back to that comparison. And if we just sweep across this, first of all, let's look at the forecast for the Mid-Atlantic. I mean, the CFS, the climate forecast, that's a pretty coarse resolution model. Has the rain certainly clearly into the Maryland and Pennsylvania areas, and certainly Virginia. And we sweep across it slowly. You can see the extent of this. A little bit of maybe some frozen or freezing precipitation over from just north of DC, like Hagerstown and Frederick into maybe Harrisburg. Canadian model has us basically has that area fairly dry. GFS brings the precip in with also a hint of some frozen precipitation there. The German model, the Icon, has the rain in there. Curiously, maybe some sleet in the Delaware Bay. I don't know about that. NAM, again, way to the south with the precip. And often the NAM and Eastern WF are very similar. And then NAM 3 kilometer, so it's the same thing. And this is RDPS. I think there's a Canadian regional model that also has a rain to the south. Or RFS, the Rapid Refresh Forecasting System version A, which is about to be phased out, has the precip way well to the south. And UK Met kind of brings it just a glancing blow. So the point here is, just looking at one forecast and saying, it's going to be rain, or is it going to be mixed precipitation, or is it going to be a dry weekend, even just 60 hours out. It's kind of interesting that this is still a forecast puzzle, because most often, 60 hours out, we're going to know if we're going to have a rainy day. Typically, I think the state of forecasting is not that good, but this is one of those instances in which there's a lot of question marks associated with that forecast. We'll go back to just the single, if you click on that, or we may have to click single image, and we'll go back to the GFS, we're there, and let's go to 72 hours and just quickly step forward and look at the weather over us. Total convection really takes over on Monday. Let's go to Monday afternoon at 81 hours of the forecast and let's do a sounding over us. See how well we've mixed. Look at that. Nice dry adiabatic layer, well mixed layer. 59 dew point at 43. John, the dew points are coming up. You might not like that.
F80
It's not quite
300
50.
on that.
Let's see, do we have a measure on this? But big thing is, that's nice. Remember last week we were looking at these really stubborn inversions that were over us. Those inversions are no longer present, at least in this particular forecast. And fairly stiff wind, so that's going to keep things, hopefully, a breezy day, well-mixed layer. That could be a nice warm day on Monday after things kind of quieting down on Sunday. Let's go ahead to 84 hours, or not 84, 105, the afternoon of Tuesday, mid-afternoon. Even stronger winds, I don't know why they do it every 2 hectopascal. Let's just take another look at the,
Wow, didn't mix that big.
wait, hold on a second. That looks bizarre. 43. Let's take a look at this, go back to the map for just a second. What is going on here? I mean, there is some light precipitation that it's in the forecast, and maybe this is a cloudy day. I didn't look carefully at the,
It's chronogenetic, I guess, because this.
Yeah, you can kinda see it.
South of us is stronger than the one that's.
yeah, you can even see the beginning of the kink in the isotherm, so there's probably a front just to our south. Let's look at the temperature.
See, it must just be clouds, huh?
Yep, look at that.
Pretty shocked.
Good eye, John. Right through here, just south of Janesville, this front. And so we're gonna be on the cold side of it. As warm as it looked, thickness-wise, again, this is what we were talking about just last week. Can't just trust that. That gets us kind of cold. And if you look at, scroll down,
Temperatures to the south.
this is what we were promised, but we're not gonna get it. Cloud cover. And this doesn't distinguish between high and low clouds, but I imagine this is a lot of high to mid-level cloudiness over us. That's gonna keep us relatively chilly. All right, let's go back to the map and get through the end of the week. Let's go to 129 hours. I like looking at the afternoons now because and we hope it's gonna be warmer. Weak little cyclone to our north with snow in the central part of the state. That's a pretty gloomy day on Wednesday. Go to Thursday, at 153. Warm convection starts to crank up, but I think we're probably gonna still be relatively chilly on this
Yeah,
day.
we're on the cold side of a warm front that's
Yeah.
developing north south.
So if we do another sounding, please, Pete.
39.
44. Right, but it could very well be 39 with the clouds. So this is going to be, and you can see mid-levels really kind of socked in here, so we're basically saturated well above the surface. So that's going to keep us just a cloudy day with frontogenesis, active frontogenesis over a region with this tilting structure, so it's going to be not particularly warm. And rather than go back to the surface map, let's just look at the sounding. Let's go ahead 24 hours to 174. If I can add. Oh, that's not good.
That's 12 Z.
That's 12 Z. I didn't add right. Okay.
Can't add.
Can't add
177.
7. Yeah. It's
Yeah,
still,
see, it's still.
that's not good. And the fact that it's close to being saturated, probably likely there's some precipitation. If there's precipitation, it will be snow. And let's look at the surface map at 177.
It's Thursday.
This is Friday now. This is past our, well, it's already passed. That weather system has passed by. And we get colder. So next weekend looks to be possibly a colder one, but we'll see. We'll wait. But big thing is, decent weekend, and then really warm, perhaps on Monday, and then things sort of falling back, temperatures crashing back into the reality, I guess, of the 30s and 40s for the rest of the week, and then warming up, not really warming up again, getting colder starting next weekend again. But at least we get a nice burst of some warmth.
Yeah.
Anyway, thank you, John. Thank you, Pete. Thank you, Andrea, for showing us that site. And I look forward to maybe some tales from the north.
Oh, yeah.
Yeah, about the field experiment. That would be great down the road. All right. Well, thank you. Have a wonderful weekend. That's what I did. Pete. My idea was to transition from, if you looked at the model comparisons page, the one that has for the pain folks has the